Welcome to class number 6, where we discuss Mercury and Venus. So we're going to start exploring the rest of our solar system, or the other planets in our solar system. And we're going to do it 2 at a time because we know there's so much less we know about other planets compared to the Earth and the Sun and the Moon and the idea of the stars. So 2 planets at a time, we're going to cover Mercury and Venus. Mercury got its name from the Roman god who's the messenger, Mercury, because simply it's the fastest planet in our solar system. It goes around the sun the fastest. And Venus was named after the Roman goddess of love and beauty, and they think that they named this planet after her because she was the brightest and most attractive of the planets in the sky. In our sky, from our view, it's the brightest wandering star or planet. So get ready, let's study these 2 planets. One of the biggest things to observe and to notice that you can't miss in astronomy is as we study the Earth, we realize that it is perfectly suited for life on this planet. So because that's what we know the most about, and because it's kind of the standard for human life, and we are humans and we are alive, everything we study about these other planets is going to be somewhat of a comparison to Earth. But what is the same about it? What is different about it from Earth? So let's look at Mercury. First thing is it's the closest to the sun, so my very early morning just started under Nancy's pancakes. Mercury, Venus, Earth are the first 3. So Mercury's the closest to the sun. It's the hardest to observe because it's so close to the sun, it's very bright and difficult to look at. So we don't know a whole lot about Mercury, say, compared to Venus or Mars. Now this is something important to remember. Note for the final exam, dun, 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 that the Mercury is not necessarily the hottest planet, although it's the closest, but it does have the most extreme temperatures. Let's see, the temperature range is from 750 degrees, that's the hot, all the way down to negative 300 at night. So when the sunny side in the middle of the day, which you're going to find out is a very interesting day on Mercury, it gets up to 750 degrees. And then in Mercury's night, when it's on the dark side of Mercury, it gets down to negative 300. So fries you and then freezes you, and then fries you and then freezes you. It'd be a terrible place to live. Now, part of the reason for that, which we'll see more, especially as we study Venus, is like our moon, Mercury has no atmosphere. So there's no gases or ball, sphere of atmos, steam or gases or mist surrounding Mercury. So there's nothing to trap in the heat like we learned about on our atmosphere. So if you were to stand on the surface of Mercury and look out, the sun would be very, very white because there's no gases to filter it out. And the sky would be very, very black because there's no gases to reflect any particular color because of those gases. So instead of blue sky and yellow or orange sun, or even red in the evening, we would just see a bright blazing white sun and a black sky, just as if you were standing on the planet or on the moon. Remember, comparing things with Earth, we'll talk about Mercury's rotation and revolution. So remember, rotation is spinning on the axis, and revolution is orbiting around something else. So rotation, spinning on its axis. Remember, rotation controls night and day, light and darkness. As the Earth turns, we move around from light to, if you're the light, move around from light, and as we go around the back of the planet, to darkness. Now Mercury has a very slow rotation. So remember, Mercury, even though it's fast around the sun, turns very slowly. So check this out. A day on Mercury is the equivalent of 59 Earth days, almost 60 days, almost 2 months you would be in the darkness. That's 1,416 hours versus Earth, which is 24 hours. So you can imagine how that would really mess up your sleep cycle, to have to, sleep for almost 30 hours and then be awake for 30 hours. It'd be an awful work day, and the work week would just be terrible. So Comparatively, Mercury turns very slow. Now remember, when it comes to weather, that having no atmosphere allows a planet to cool very quickly. So when it's on the dark side, there's no sun putting energy into that side of the planet, warming it up, and there's no atmosphere to hold it. So for 30 days, all the heat is escaping on the cold side, which gets you down to that negative 300 degrees. But then when you come back to the hot side, you're facing the sun with like that sun beating down on that side of the planet for 30 days straight. So that's why you get up into like 700 degrees hot, because you spend 30 days in the daylight without it ever having a chance to cool down. So Mercury, slow rotation. But when it comes to revolution, Mercury is very, very fast. It goes around the sun really quick. So instead of 365 Earth days to go around the sun, making a year, the year for Mercury is 88 days. It's flying around that sun. It's like it's a third, less than a third the time of Earth years. So it's kind of interesting that the year is just slightly longer than the day on the planet Mercury. So it wouldn't be a very good place to live. It would be extremely hot and cold, and the days would be super, super long, and the nights would be super, super long. So you would be a very difficult place to sleep and to function, unless you really liked to work for, 708 hours a day, when it's light out. So 88 Earth days. Now, I notated it this way because it's kind of hard to refer to days and years, because if we're talking about Mercury years, it's 88 Earth years. So again, because Earth is where we live, and Earth has all these perfections that keep us alive, we measure everything by the Earth. So we say 59 ED, or Earth days, is equal to a day on Mercury. 88 ED, or Earth days, is equal to a year on Mercury. And this is rotate, and this is, you guess it, revolve. There you go, Mercury's rotation and revolution. Like all planets, Mercury is a satellite around the sun, which means that it orbits around the sun. That compares to revolution, not rotation. So Mercury, in its path around the sun, has a very elliptical orbit. And let's talk about what that means. This is what we call a circular orbit, that no matter where it travels, it's the same distance from the sun. So if that's 100 miles, and that's 100 miles, that's 100 miles, that's 100 miles. So a circular orbit would be the same distance in its path, same distance from the sun in the entire way through its path. An elliptical orbit is more like an oval, which means out here it's farther away from the sun, then it gets closer to the sun, and then it shoots way out here farther, and then closer, and then farther. And so you could end up with all kinds of strange patterns. You could even have one that theoretically, something could orbit like this around the sun. That's kind of how like a comet might orbit. It comes from way outside our solar system, comes in, whips around the sun, and then disappears. So most of the planets are more circular in their orbit, except for two. So I want you to remember these two planets that are less circular and more elliptical, and that is Mercury, and the closest, and Pluto, the farthest, except where they're still debating whether they're going to call Pluto a planet or not. I guess they said Pluto's out, it's not a planet, and then now there's some people saying, nope, Pluto's back in, it is a planet. But regardless of whether you want to call it a planet or not, just remember that Mercury and Pluto are both the most elliptically orbiting planets around the sun. We're going to talk about some of the features of Mercury and what the planet's like, except I forgot to do this at the beginning. I wanted to show you a couple photos and images of Mercury. And so the first one here is just simply a picture of from Earth trying to look at Mercury and seeing it in front of the sun, and we see how hard it would be to observe because of the big bright sun behind it. A little tiny black dot, because we'd be seeing the night side of Mercury. So there's an image I wanted to show you just of Mercury in relation to the sun. And then this next image that I wanted to show you of Mercury is just an artist's rendition of what it would be like to live on Mercury. You can see the big rocky mountains and hills, black sky, bright white sun because there's no atmosphere. So it's an artist's image of what it would look like from the surface of Mercury because of no atmosphere. So let's move on. Talking about the features of Mercury. It is the smallest planet in our solar system, which means, let's do a comparison. So if the Earth is a baseball, Mercury would be a golf ball. And so compared to the Sun, they're both tiny, but compared to each other, the Earth is bigger than Mercury as far as these terrestrial planets go, baseball versus golf ball. The surface, it would be a dry, dusty, empty, rocky, lonely, awful place to live, like you can see in that picture from the artist's rendition. Just dry, black sky, bright white sun. Not a very habitable place. Alright, so the other thing we noticed too about Mercury is that it is covered with craters where asteroids or space rocks have hit it. So think about it. Why would the asteroids be able to hit the planet so easily? Because no atmosphere to burn it up. So the biggest one they found on Mercury is actually the size of Texas. Huge asteroid impacted it, made a crater the size of Texas. So it might be worth noting too as evidence for a young Earth, because you have some people who believe the Earth is 6,000 to 7,000 years old, created by God, and you have other people who believe that it's millions or billions of years old, and nobody was there, so we don't really know, so all we can do is look at the evidence to say, hey, is there any evidence that says the Earth might not be millions and billions of years old? And then we look and we say, hey, is there evidence that says that the Earth might be 6,000 or 7,000 years old? And so craters is one of those pieces of evidence that there's not enough craters that it would look like it was there for millions and billions of years, because there's still, like on the moon where there's Maria or plains, there's still places, even though there's lots of craters, there's still places that haven't been scarred up. And you'd think after millions and billions of years that there would be all these scars and craters everywhere, and that's just not the case. So just another piece of evidence, even though there are lots and big craters, still not as many as you'd expect. So let's talk next about space exploration. Alright, just a quick note about how we explored the planet Mercury and some of the trips out there. In 1973, we launched a spacecraft called Mariner 10. It was unmanned to go and explore Venus and Mercury. It didn't land on the planet. They just kind of flew past, taking pictures and collecting data. In 2009, there was another one called the Messenger that went out to gather data. And most of these, I want you to look at the supplemental material and you'll see some more information about it. Last thing before we go on to Venus is I wanted to just describe, make a distinction between planets. This is kind of extra, probably should have been in the middle of the presentation. But there are some planets that are called terrestrial. That's Mercury, Venus, Earth, and Mars. It means they're rocky, they have Earth soil, they're solid planets. Versus once you get out past Mars, they're called gaseous planets because they're big, huge balls of gas, usually much bigger than the terrestrial planets, surrounded by huge balls of gas. So you have two different types of planets: terrestrial, Mercury, Venus, Earth, and Mars, and then all the rest of the ones out there further are the gaseous planets. Just hold on to that little bit of knowledge. Now that we've got our comparison gears turning and we understand how we're going to compare planets to Earth and to one another, second planet up from the Sun, Mercury, then Venus. Venus is the hottest planet. Now you probably, if you were like me, would have thought Mercury was the hottest planet because it's closest to the Sun, but that is not true, as we shall see in this study. It is about 870 degrees all the time. Interesting how Mercury was the most extreme in temperature, but Venus is the hottest. So this will be a fun study to see why that's the case. The surface of the planet is covered with lava, molten rock. It's just like a big volcano kind of a planet. There's still hardened spots and solid areas as well, but it's like a constant destruction, a burning place. There's just nothing there except fire and burning and heat and rock. So even though that it's kind of got somewhat of a liquidy surface of hard spots like our land and lava like our oceans, it's still considered a terrestrial planet, one that's made of like earth and rock, as opposed to the gaseous planets that we'll study about later. Let's compare atmosphere next. So Mercury had no atmosphere, but the atmosphere of Venus is very, very different from that of Earth. It's a heavy, thick, gaseous atmosphere. And unlike on Earth, where it has oxygen that we need to live, the atmosphere of Venus is made up of sulfuric acid. So even if you were to land something on the planet, you would have to make sure that it was able to withstand this burning, caustic environment of heavy, thick gases that burn. So the atmosphere is very different, not inhabitable for life. Second, that atmosphere actually acts like a lid on a pot that traps heat in, which is why it's the hottest planet. So remember, Mercury is able to vent off all its heat on its long night on the back side, while Venus has this thick covering or this blanket around it. Remember we talked about the Earth's atmosphere in class being like a blanket that traps all the heat in so it can't escape. So even though it, on its rotation has a dark side, the heat stays insulated like a warm blanket at night. The other thing too is that there's a lot of fast moving winds that the planet, as we'll see, rotates very quickly. And those fast moving winds act like a convection oven. A convection oven is like a regular oven, but with a fan in it. So it blows the hot air around. So these fast moving winds blow the hot air around the planet. So even on the dark side, where there's no light, that the heat from the light side that's coming in blows around and gets that heat to the dark side. So the planet Venus is made to be a hot box with this big, thick, sulfuric acid gaseous blanket holding in all that heat. So that is the atmosphere of Venus. You wouldn't want to live there, promise you. Next up for comparison is rotations and revolutions around the sun. So I misspoke. I think a second ago I just said that the wind on the planet is caused by its rotation. That's a mistake. It's caused by the heat. So as it gets hot, the heat propels the winds. Not the rotation, because the rotation is actually very slow. So Mercury had a very, very slow rotation, and also Venus. Venus takes 243 Earth days to turn around on its axis. 243 days. That would be 121 day night and 121 day. So again, not very conducive to live on. You would have really long sleep and work cycles. Something else about Venus that's very interesting too is that Venus and Uranus are the only two planets in our solar system that spin the opposite direction, which means your sun would rise in the west and set in the east. It'd be very strange. Instead of this way, the sun would come across the sky the opposite direction. So rotation, opposite direction, very slow. Revolving, or revolution, or length of time around the sun is 225 Earth days. So the idea is that as you go out further in the solar system, the further out you go, the longer it takes to revolve. So Mercury is nice and close, so it's got a little orbit. And then Venus has a bigger orbit. And then Earth has a bigger orbit. All the way to Pluto, which probably would cover this whole board for an orbit. So it means that I bet you Amina's going to ask this question, well, why does it take longer to make this orbit? Well, because it's got more distance to travel. The bigger the circle, the farther it has to travel to get all the way around. So, have you caught it yet? 225 Earth days is a year. 243 Earth days is a rotation, or a day. If you were to live on the planet Venus, a year, 225, is shorter than a day, 243 days. So the year on Venus, a Venus year is actually longer than a Venus day. Crazy place to live. I don't even know how you'd measure your age if you lived on Venus. You'd probably measure your age in days rather than years or something like that. So just something to take into consideration. Remember, years are the amount of time that it takes to revolve around the sun, while a day is the rotation, which makes the sun go up and the sun go down. Cool facts about Venus. Okay, a long time ago, before they explored much of the planet, everyone used to think Venus was Earth's twin because they're about the same size, about the same mass. But as it turns out, as they get to the planet and explore it, they really aren't a twin at all. They're very, very different. People used to think maybe dinosaurs lived on Venus and things like that. But it turns out that's not the case. Not much is going to live on Venus, the big fiery burning planet with sulfuric acid for an atmosphere. So, not Earth's twin, although it is very much the same size, very close to Earth in distance from the Sun, very much the same mass. So how did they start exploring it? Well, there was 1962, there was a spacecraft called the Mariner 2, did not land on the planet because of the hostile environment and things like that. So you figured you can't take a picture of this planet and see the land because there's all this gas over the top of it that makes it so you can't see down into the planet. So how did they figure out what this planet looked like? How do they map the surface of the planet? Well, they used something called radar. So here's my picture to try to explain what radar is and how it works. So here's your satellite floating up in space, nice little space satellite there. And what it would do, like a bat or something like that, it would shoot out sound, because remember light would just get caught up in the atmosphere, would shoot out sound down through the clouds in the atmosphere, and the sound would hit the land and bounce back up, and measuring the amount of time that it took the sound to go down, bounce, and come back, they could figure out how far away it was. Because it would be a consistent speed of the sound, and they would know that if it took longer to come back, it probably had to bounce farther. So the satellite would go across the planet, bouncing off the sound, and it would bounce all the way down, and it would come back and it would say, oh, 4,000 feet. And then it would come over here, and it would bounce down, and it would say, oh, 2,000 feet. And it was very quick in between those things. Oh, 1,000 feet. So it could tell, wow, there must be a very steep slope in a mountain. And so it could measure it back down to plains and valleys and mountains, and even figure a cliff, because if right here it was 4,000 feet, and then right here it was 6,000 feet, then you'd know, wow, that changed very quickly, it's probably a cliff. So they mapped the surface of Venus using radar, because it would pierce the clouds, as opposed to being able to use visual line of sight, because you couldn't see through the atmosphere. So Mariner 2, 1962, was one of the first spacecrafts to map Venus. Alright, some last wrapping up facts about Venus. Venus is a very well explored planet. Mariner 2 may have been the first one to go there, but there have been 22 explorations, or 22 spacecraft sent to explore Venus. That's quite a bit. Venus has phases like our moon, so you kind of have the full moon, and then the gibbous, and then the quarter moon, and the crescent, and then the new moon. So just like the moon has phases, Venus does as well. The only problem is it's so far away that you can't see it easily. So with a telescope, you can actually watch it and see that Venus goes through the phases. So let's pretend it's a full Venus, kind of like a full moon. It is very, very bright. Remember, that's how it got its name, being the most bright and attractive star in the sky. Only the moon is brighter than Venus in the sky when it's showing. So if it's a full Venus, and at sunrise or at sunset, it is the most bright thing in the sky. Now remember, Sirius was a very bright star, and it is the brightest of the stars, but Venus is a planet, so that doesn't count. It's not competing with Sirius for the brightest star. It's the brightest object after the moon. So, last couple of facts there about Venus. We covered Mercury and Venus today, and we're just going to keep following those planets and all the things out to the end of our solar system.